So we're doing quadratic models. How many of you guys remember the shape of a quadratic? What is the shape of a quadratic? Yes. An S? No, that's a cubic actually. Yeah. Yeah, it looks like this, and it's like a parabola. So it has this look to it, okay? It could also be this way. It could be upside down as well, right? Side is not quadratic. That would be something else. Okay? All right, so linear functions are in the form. You guys remember this from a couple days ago? We had f of x equals what for a linear function? Mx plus b, correct. Okay? And they're appropriate for solving, appropriate for situations involving a constant amount of change. Exponential functions are in the form of what? Do you guys remember that from yesterday? Yep, exactly. AB to the x. Okay? And they are appropriate for solving situations where you have a constant percent of change. Okay? So quadratic functions, and you guys really should probably have done a lot of this last year, maybe some in Algebra 1. I'm not sure what you did here, but it's going to be f of x equals ax squared plus bx plus c. Yeah, y and f of x mean the same thing, really, okay? But sometimes when we're talking about functions, they like to use the f of whatever or the h of whatever. Yes? Yes. We're going to be doing some quadratic formula, and we're going to be finding the axis of symmetry and fun stuff like that. Okay, so these are appropriate when you think data will increase to a peak. And then drop. Okay? Or when the data will decrease to a low point and then come back. Okay, quadratic formula. Man, I tell you, quadratic functions are found so much in life, okay? For one thing, you always use it when you're dealing with gravity. So if you throw a ball up in the air and it comes back down, that is also used by using a quadratic formula or quadratic function, okay? All right. So let's look at two examples of the graph of these. You're going to have one that looks like this, and please excuse my messy parabola, but it looks like this. Okay? Where it crosses the y-axis, that's called the y-intercept, and I'm going to shorthand that by y-int. That's right there. Okay? That point is always at 0, C. And then I'm talking about the C that you see right here. No pun intended. C that you see. Okay? The X-intercepts right here. So I want you to label those as X-ints. Do you guys remember how you found those? At the zeros of the quadratic, how do you find those? Plug in 0 for y, and then how do you solve it? Quadratic formula. Okay? So the x-intercepts are often called the zeros. You might want to put that down. Zeros of the... Okay? The very bottom of the quadratic is called a what? The what? Kind of an apex, but that's not what we usually use it for this. Huh? Vertex. Yeah, yep, it's the vertex. Okay? And in this case, is it a maximum point or a minimum point? This one's a minimum. Okay? Do you guys remember what goes through the vertex?
Oh, I know, there's the line of symmetry.
Yes, this is a line of symmetry. Okay? Line of symmetry. Now, likewise, I can make a parabola here.
Wait, you didn't touch the line.
I know. It doesn't always.
That means there's no real zeros.
That's right.
Oh, God.
So that, in this case, there's no x-intercepts. And that means that the quadratic formula that you get will have some i's in it. Okay? Yeah, well, I'm not going to be working on i's today. But I'm just saying this is what it looks like. Okay? Eyes make me want to cry. Okay, so this point is also called the what? The y-intercept. What is this point right here? That's the vertex. And is it a max or a min? Yep. And then once again, our axis of symmetry goes right through that vertex. Like that. Okay. So if a is greater than 0 in the equation, remember we're looking at ax squared plus bx plus c. If this a right here is greater than 0, the graph opens which direction? Up. Good. If a is less than 0, then the graph opens down. Okay? The value of c is always the y-intercept. And the x-intercepts can be found using the quadratic formula. I'm going to write down, yes. So we have minus b, and I'm going to do the minus one first, Hunter. Hold on.
Shouldn't it be plus or minus?
Yeah, if you do it all at once. I'm just writing 2 points here, though. At that point and at minus b plus. So you guys have seen plus or minus. You can do it.
Wait, why are you doing that in pairs?
Why am I doing it in 2 points?
I thought the quadratic formula was just one thing.
Yes, you are familiar with doing minus b plus or minus square root of b squared minus 4ac over 2a, correct?
Yeah.
But I'm giving you 2 x-intercepts right now. One is a negative, and one is the positive. Okay? All right. So you have 2 of them. Okay? One of them you're subtracting, the other one you're adding. Two A. There. Okay? So the maximum or the minimum point occurs at the mean of the x-intercept, or when the x equals, dun dun dun, minus b over 2a. Do you remember that? Okay, this right here is your axis of symmetry. Okay? To find your y-coordinate of the max or min point, you're going to substitute the solution back into the original equation. Okay, so let's consider this function right here. It's got an equation of 2x squared minus 3x minus 2. And it says we need to find the x and y intercepts of the graph. Well, the y one is the easiest one to find. Because what do we need for y? That negative 2, right? So the y-intercept is going to be 0, negative 2. Yep. Okay? But the x one is more difficult. So we need to find the x-intercept. So A is what in this case? 2. And B is negative 3. And C, negative 2. So let's put that into our quadratic formula. We have minus B, which is minus a minus 3. Okay? Plus or minus the square root of negative 3 squared minus 4 times 2 times negative 2 over 2a.
Over 2, 2.
Yep, 2 times 2. All right? Okay, so we know that a negative of a negative is a what?
Positive.
So that's going to be a positive 3. And what is negative 3 times negative 3? 9. 4 times 2 is 16. Being that we have two negatives here, notice that we have this negative here and another negative here. It's going to be a plus. So plus 16 over 4. Okay, what's 9 plus 16? Yep, 25. So this is going to be 3 plus or minus 5 over 4. So we got two possibilities here. 3 plus 5 over 4, which is 8 over 4, which is 2. And 3 minus 5 over 4, which is negative 2 over 4 or negative 1/2. Okay, so our two x-intercepts are 2, 0, and negative 1/2, 0. So part B says we need to know if it's a max or a min. Notice that A is 2. It's positive. It's a min. Yep. Since A is 2, it's a min. So a minimum. Yeah. Yep. So now we got to find the axis of symmetry. So
How do you know that? 2 is the minimum.
because anytime A is greater than 0, it's going to be a minimum. It's going to open upward.
Oh.
And anytime A is less than 0, it's going to be a max because it's opening downward. Okay? Okay, so we know that it's a min. I'm going to go in and find the axis of symmetry right now. We know that the axis of symmetry is minus B over 2A. So we have minus a negative 3 over 2 times 2, which is going to be 3/4. Once we have that, we need to plug that back into our original so that we can find the y coordinate of the vertex. Okay, so we are going to take this original right here. It'll be 2 times 3/4 squared minus 3 times 3/4 minus 2. Okay? Yeah. So this will be 2 times y to the times 9/16 because that's squared. 3 times 3 is 9. 4 times 4 is 16. Okay? We're trying to find the y coordinate of the vertex.
Wait, but isn't 2 minus 3? Or JK, negative 1?
Uh,
Wait, where's the
then the next part is 3 times 3 is 9, so that'll be 9/4 minus 2. So 2 times 9 is 18 over 16. And I want to change this one into 16 for the bottom to get a common denominator. So I'm going to multiply it by 4. Oh, wait. This is going to be, you guys, this should be an 8 on the, hold on. Okay, hold on. Okay, so 9 times 2 divided by 16, but 2 goes into 16 8 times, right?
Wait, getting these numbers from.
All right, so now let's go down to the next problem.
I think I got it. I think so.
First of all, what is my A, B, and C in this one? Okay, A is -3. B is -4, and C is 7.
So then the y would be 0, 7?
Yep, y-intercept is 7. That's the easiest one.
Okay.
Okay, so y-int is 0, 7. Okay, so now we need to find the x-intercepts.
So negative 4 plus or minus square root of -4.
Yep,
Minus 4, -3, and 7.
yep,
And then all over 2, negative.
yep. Okay, so this is what you should have for your formula.
And then
So a negative of a -4 is a +4. -4 times -4 is 16. Yep, 12 times 7 is 84. And notice that there's 2 negatives here. So it's going to be a positive 84 over -6. 100. Isn't that nice? Every once in a while it comes out nice for us. Not all the time. So this will be a 4 plus or minus 10 over -6. So 4 plus 10 is just going to be 4. Yeah, -6. It'll be -14/6, or if I simplify that, 7 over 3. Good.
why is it negative? What is negative?
Because there's a -6 on the bottom. Okay, so that x-intercept is -730.
Wait, you forgot minus.
I know, I haven't done it yet. So now we're going to do 4 minus 10 over -6. That'll be -6 over -6, which is 1. I like that one even better. Okay, so those are our x-intercepts.
Okay, and then B, the A equals -3, so then it would be max.
Yep, the A is less than 0, so the A is going to be a max. So the parabola is going to have, the vertex is going to be a max. Because A is less than 0. Okay, so -b for our axis of symmetry in this case is -4 over 2 times -3, or 4/6. And if I were to simplify that,
Are you doing B right now?
yes, -6, thank you. And it'll be -2/3.
Wait, so why do you have to find that to find
The vertex? You need, this is the x value of the vertex.
Oh, we just knew those
the... It doesn't say find it.
It says find its coordinates. This says fits its coordinates. I mean, it was a typo. Should be find its coordinates.
Wait, what does it mean? It's
No, it means like if it's
No, actually it was a typo. It was supposed to be find its coordinates. Yep.
Oh.
Okay. Sorry about that. Okay, so I'm going to put this in for f of x of negative 2/3 into the original equation. I'm just going to rewrite the original equation first. Okay? Sure. So we're using that original equation from up here. We're going to replace those x's with this coordinate right here. Okay? So this will be,
It'll be negative 3 times negative 3 squared.
yep,
And then negative 4 times negative 2 over 3.
yep,
Plus 7.
that's right.
And then I got 4 over 3.
So this one's going to be 4 over 9.
Oh, I had to square that too.
Yep. And then negative 4 times negative 2 is a positive 8/3
And then plus 7.
plus 7.
And then can't you just divide negative 3 by 9?
So yeah, I can reduce this before I go on. I'm going to change my pen color here for a second. So 3 goes into 9 3 times.
Oh, 3 times.
Nope. Yeah, 3 times. Okay? So negative 4.
I don't really understand how
So she's just dividing.
should it be negative 4?
Yep.
Or should it be 3? Why would it be negative 4?
Because this becomes a 1. So negative 1 times 4 is negative 4
So,
over 3 plus 8/3 plus 7. Okay, and then I need to change the 7.
21 over 3.
Okay, so that would be 21 over 3. So we have negative 4/3 plus 8/3 plus 21/3.
So then you have negative or negative divided or plus 21.
Yeah, so 25/3, right?
What is that telling you? Where your vertex is?
This is my y coordinate.
So then your thing would be negative 2, 3, comma 25, 3.
Yep,
And that would be your vertex?
yep.